For starters, what are the two main different parts to combinatorics? So that's, I'm putting them together. So we've got permutations and combinations.
Order and number. That's what I'm
And what's the other main, and I'll spread that out a bit actually. Combinations. What's the other main section? Binomial, yeah. Okay. So for permutations and combinations, what are, or let's start with what's the main word that they will often use that tells you the difference between a permutation and a combination? Give me one.
Arranging.
And give me the other one.
Selection.
Right. So this one we'll talk about arranging. This one we'll talk about selections, hopefully. They're getting better with the language, okay? Because in arranging, the order matters. Whereas in selecting, the order doesn't matter. Okay, so if we're dealing with that, in permutations though, there are still kind of two sections to that. There's the factorial notation and then a proper permutation. So, what is the difference between straight factorial notation and true permutations?
Factorial is all of them.
Right, so you use every element. Whereas this one you only use some. And that's what that whole thing means. I'm taking R from a possible N. In combinations, can you ever have a situation in which you use every element?
No.
Because the answer would always be one, right? If the order doesn't matter, in how many ways can I arrange you guys or select you guys to be in my class? And I want all of you. You're either in or you're not in, right? So there's only one way I can put you all in my class. It doesn't, whereas if I talk about in how many ways can I arrange you to sit in my class, then the order matters. So for the combinations, you can only do it if you're selecting some. Okay. In our factorial notation then, can you see Linda? You right? In our factorial notation, I probably shouldn't go any lower, should I? What are some of the special sorts of things then that we might need to do?
So repeated, like if you have like a word and then repeat letters.
So if there's repetitions, yeah? Then you're going to have n factorial over p factorial, q factorial for all the different repetitions, right? What was the other, one particularly, but two extra special things that happened with factorial notation?
Do we have the circle method and the break?
Circle, perfect, yeah. So what was the difference between a straight line and a circle?
So we had to minus 1.
You had to take one away. And why did we take one away before we did our factorial?
Because the first one never matters.
Yeah, you had to lock in your first spot, because otherwise, when you're sitting around a table, that's not changing the order in which you're sitting if everybody just moves one seat, right? You're still sitting in exactly the same position in relation to everybody else. So you've got to lock one person in and then arrange them around that. And that's why you take one away. And if instead I did a bracelet or a necklace, do you remember that one? You can flip it. So remember, where if people are sitting around a table, if I have Peter sitting on this side of me and I have Sandy sitting on this side of me, that's a different order to the boys sitting on the opposite sides of me. But if we were all beads on a necklace, so you could flip the necklace over, then as soon as you flip it over, without me physically moving the beads, I can have the reverse order. That it appears from the other side that one's now on the right and one's on the left, whereas on the looking above it looked like one was on the left and one was on the right. So therefore we have to halve our number of arrangements when we're talking about a bracelet. And I'm sorry this is down the bottom, but I just want to fit it on. N minus 1 factorial over 2. Okay, so what is the factorial way of writing NPR? Starts with N factorial.
N minus R
Factorial.
Now, does this also have the R factorial in the denominator or not?
No, it's combination.
And think about this. If you divide by another value, you're going to reduce the number of arrangements, right? Which one's always going to have a smaller number of arrangements? What did you say? Which one's going to have a smaller number? If I'm doing combinations, because remember you've got to eliminate all the double ups, the ones where if I've got AB, that's in a permutation, AB is different from BA. But in a combination, either A and B are in or A and B are not in. So the combination is the one where you have the extra division. Okay. What else do we need to know? There's probably now just a couple of important little extra bits. What is 0 factorial equal to? 1. Okay. And if we're talking about, don't forget this one. If I've got n plus 1 times n factorial, this was to do with some of our proving. Do you remember that that equals n plus 1 factorial? Okay. So that's kind of putting our permutations and combinations part together. We've still got to do our little bit on the binomial. I've again got some questions for us to have a look at. And we've obviously got to move ahead with our trig, but I just want to keep you going with this stuff in preparation for your task as well. Okay?